Okay, welcome back. Section 2.4. Remember, we skipped 2.2 and 2.3. Section 2.4, very similar to 2.1, only we're dealing with inequalities. The only difference is that an inequality means not equal to. It means it could be equal to, but it could also be greater than or less than, and it doesn't have to be equal to. So that's what we're dealing with inequalities. The textbook gives us a definition on page 149. The addition property, it's the same as the addition property for equality, and then they don't really give us much else until the multiplication properties. Now I want to point out for the multiplication property, you can skip over to 152 and look at that chart. However, what I mentioned in section 1 about making sure we get a positive variable, if we do that, we don't have to worry about this stupid rule where you have to switch the sign. I don't want to switch the sign or the symbol. Don't worry about switching the inequality. That was one of my biggest headaches when I was learning this, is did I just divide or multiply by a negative? If I added over to the right and ended up with a negative remaining, it would confuse me, and I had to ask myself if I just changed it or not. So I'll explain that as we work through this, but shoot for moving to make a positive variable. In my mind, it's easier even if you have to take one extra step to move a variable to make it positive. That way, your inequality symbol remains the same all the way down the line. So page 153 says how to solve linear equalities in one variable. Again, one big issue with algebra is terminology. People get worked up about the terminology. They use big words we're not used to hearing. Don't worry so much about knowing the terminology. Just understand the process and the concept. Okay, I think we can just jump into it. Yep, let's jump into 2.4. I have it starting with number 17. So let me switch the screen. Okay, problem set 2.4, number 17 says solve each of the following and then graph. Now when they say graph, we're talking about a number line right here. Chapter 3 is when we get into graphing on a coordinate plane. So for number 17, they give us 1/2 is greater than or equal to -1/6 minus 2/9. This one's loaded with issues that people have. Many students dislike inequalities. They want something to just be equal. Many students hate fractions, and then many others hate negative numbers. So we got it all in this one. Now what I'm going to say, and I wish I had my green pen, but what I will do first here is possibly eliminate the fraction. You can get rid of it. And in this case, if I multiply, I know my 9 means 2 doesn't go into 9. So I try 9 times 2 is 18. Both of these go into 18. So there's my LCD. I'm going to multiply everything by the LCD. When I do, I have 2 divides into 18 9 times. Then I have greater than or equal to. That doesn't change. Then 6 goes into 18 3 times. 3 times 1 is 3, and that was a negative. So again, I'm just taking my -1/6 and multiplying by 18. It becomes -3. And then here, 9 goes into 18 twice. 2 times 2 is 4. That was a negative. So there we have it. Now, what I was mentioning before is I am going to stick to this. I know it's an extra step here. But if you take one extra step and get a positive variable, you don't have to worry about the multiplication rule or division rule of changing the symbol, the inequality symbol, if you multiply or divide by a negative. So follow me here. What I am going to do, well, maybe I should go column-wise. I'll go down this way. What I'm going to do is move my 4x. I know I don't have to. I could solve without doing that. It'd be quicker to just poof, move this over here. But by doing this, I essentially rewrite this problem. I'm adding 4x to this side. I took it away here, it's gone. And I have this. Now from here, I know I have a positive variable. This inequality symbol never changes, stays the same. I don't have to worry about a little mistake at the end and having, if I forget to switch my sign after dividing by a negative, I get the wrong answer and the wrong graph. So I've made it positive, so I don't have to worry about it. So I have 4x. What I'm going to do is subtract 9 from each side. 4x greater than equal to a negative 12. Now I'm dividing by a positive. When I divide by a positive, I do not change this inequality symbol. Yes, I have a negative, but I didn't change it. It's just been negative. I had a negative divided by this positive 4. So I have x greater than equal to negative 3. And I'm going to draw the whole, well, most of a number line. We'll do it this way. So greater than or equal to, when you have an equal to, you want to box it in with a bracket. You may have learned, I remember I learned with an open circle versus a closed circle for equal or not equal. This is replaced by parentheses, this is replaced by bracket. We do that because that's how we write the answers using parentheses or brackets. So we might as well get used to doing that on a number line as well. So there's my graph. It's just greater than or equal to negative 3. Here's my negative 3. It's just getting bigger for infinity. So if I were writing this, I would say it's greater than or equal to negative 3. And let me double check and see. Oh, yeah, they don't even write. We won't even jump. We won't go ahead to that yet because they don't even do that yet. So I don't want to get ahead of the ball game. Oh, no, wait, they do later on. They do later on. So we'll just keep going. This is how you're going to write it when they ask. They're going to ask for interval notation. We're ahead of the game a little bit. But then this will make sense. No, not notion. It's not a notion. It's a real deal notation. So there is the graph that they asked for 17. In number 17, they just needed this for the answer. If they asked for interval notation, you would write it that way. Okay, that's 17. Let's go to 31. Number 31 is where they say write your answers in interval notation, because now they're not asking you to graph. They give us 2 times 3y plus 1 less than or equal to negative 10. So I need to first distribute. So I have 2 times 3y is 6y, 2 times 1 is 2, less than or equal to negative 10. Because I have a positive variable already, I am not going to move that. I am just going to move my 2. So whatever I do on the left, I do to the right. The goal is isolating this variable. If I subtract 2, it goes away. So I subtract 2 over here, and I have negative 12. Then I simply divide by 6. I have y less than or equal to negative 2. This one doesn't want it graphed. Now, I still will graph it so that you can visually look at this. Here's our number line. I'll go 1 here, 0, negative 1, negative 2, negative 3. Now we're talking less than or equal to. When we talk less than, we're going left. Less than means left, greater than, we're going right. So we're going this way all the way to infinity. It just says y is less than or equal. It's everything less than negative 2, including negative 2. To write this out, interval notation, the infinity symbol just means forever, every number that way. If it's going left, just put a negative and put it on the left. If it's going right, just put a positive and put it on the right. So it's going all the way down. Our value for y can be anything equal to negative 2 or less than. Since it's equal or less than, I'm using a bracket. So there's our answer. There's our interval notation answer that the book is looking for. When they say write in interval notation, this is what they are looking for. Okay, then I'm going to do one more. Number 50, I think, is just moving. This says solve, I'll write it here. Solve each of the equations for y. And number 50 gives us negative 2x minus 5y greater than 5. Some students get a little thrown off when you're not truly solving the problem. You're just moving things around. They want you to solve for y. So figure out what you are doing is you are asking the question, what is 1y? What's that value? Well, that means you need to isolate y. You want to get y by itself, and you want one of them. So for starters, here's a y. Again, I'm still going to go over here because they want a positive y. They want 1y. I don't want to switch this sign. And this is the last one I'm doing, so I can write it all down here in a column. So I have negative 2x. I subtract y. I have 5 minus 5y. I just moved it. Whoops, sorry, 5 plus 5y. I just moved it over here. I said, okay, I'm going to move the y. So plus 5y plus 5y. Now, I can subtract my 5. So I have negative 2x minus 5 greater than 5y. Now, they just asked, what is 1y? Solve for y. I'm solving for y. I can't solve the problem because I don't know x, but I know what 1y is. 1y is 5y divided by 5. That will give me my 1. When I do that, I'm going to do one extra step here. I'm going to say you're dividing everything over here by 5. The easier way, cleaner way to write this is 2/5 x minus 1 is greater than y. So y is less than all that. The book might flip it. Yeah, the book flips it. Doesn't matter how you write it. The book writes y less than negative 2/5 x minus 1. It's the same answer. What I did is right here, when I moved my 5y over, I allowed myself to keep that inequality the same all the way down. Sorry, I cut that off on the dot cam. All the way down. I never switched my sign because I moved my variable in the first place to make it positive. Okay, hopefully that helps. We'll jump ahead to section 2.5 next.